All right. Wake up. You guys have fun at the party last night? Yeah, that's what it looks like it. So yeah, I'm really happy for all you guys to be here. I'm excited. I'm excited you guys came to learn about networking at 10 a.m. After the party. So I'm honored by you guys. So I'm Nick Matthews. I'm a solutions architect. I spend a lot of time with customers and our partners working on network architectures and things like that. So today we're going to be talking about connecting many VPCs. We've also got Vicente up here. He's going to join us later and talk a little bit about his use case. So let's get into it, man. This talk is about many VPCs. So what does that mean? When I talk to customers, usually one of the first questions I have to ask is how many VPCs do you have? Sometimes it's one, sometimes it's three. Where do you think you're going to be in a year? Is it 20? Is it 30? Is it 500? Is it 1,000? Because you might start off with 10, then you have 20, and you figure out how that goes, and then before you know it, you got hundreds, and it's sort of an interesting problem to go try to work on and try to solve. So that's the topic for today. Is you got a lot of VPCs. What do you do? So let's start off with Virtual Private Cloud, VPC. Hopefully you guys know this is a 400-level session, so this is my only teaching slide. But they say a virtual private cloud is it closely resembles your traditional network, and we do it in the cloud, right? So that's mostly true. So I've been doing a lot of network engineering, a lot of customer architectures, those kinds of things. This is what a pretty standard sort of on-premises network looks like. So you might have two data centers, you might have some sort of fiber between them. You probably have some sort of wide area network or WAN, maybe doing some MPLS. You probably have some VPN going on. So if you turn this into VPC and AWS stuff, it mostly fits, right? So we can still do VPN. That private fiber sort of turns into VPC peering. We put things into instances. We connect the WAN in through AWS Direct Connect. And this is a mostly one-to-one sort of equivalency. But there's some differences. So what are some of the differences with VPCs? So we say it resembles a traditional data center, but how many of you guys created a data center in seconds? It doesn't happen, right? You can go into the console and just keep clicking, and you've got 10 data centers. That doesn't happen on premises. If you do, we probably want to hire you. So it's really easy to create VPCs. Another component is the access models. So back in a prior life, I used to walk around in data centers. I had my Cisco Blue console cable, and I could probably plug into customers' routers and do stuff. I would never do that because it's totally wrong, but I could probably do that. But there was inside that data center, there was not a single access credential that got me access to everything in the data center. I'm pretty sure that mostly because those people don't talk to each other very well, so the storage people and whatever. But there was no single credential that would get you access to everything in that data center. In a VPC, you have a root account. The root account has access to everything. And that's why we have to be very, very careful with that root account. And so that's a difference. One of the other things is ownership. So who are my network people in the room? Pretty good portion. But there's a lot of people that aren't network people that are creating networks. So developers, line of business folks, application people, and they're coming and they're trying to figure out how networking works. And so you may end up in a scenario where those guys just want their own network or end up creating their own networks. And that's a difference as well because that typically doesn't happen on premises. So one of the components here that we're going to talk about is many VPCs. And this usually comes up because there's a prior conversation at the customer, right? So there's this sort of divide that I see. It's a gradient more than a binary sort of option. But do I want to have really big accounts in VPCs and get sort of granular there? Or do I want to have lots of accounts with maybe their own VPCs? And so there's a couple of things that we're going to walk through real quick. So if you do the sort of large approach, there's less infrastructure, there's less networks, less accounts to set up, obviously more on the other side. Whenever you start getting into controlling that environment, you're going to talk a lot more about identity and access management, reducing roles, making sure you're going to be doing a lot of tagging, resource restriction, and controlling a lot of things within that VPC because it's sort of a big shared environment. So those are some of the things you're going to be looking at. In the case where you have lots of little VPCs or lots of accounts, it's really more infrastructure related. So it's more about VPNs, Direct Connect. You probably want to set up some standards so that your public subnets and your private subnets have some sort of routing thing you've agreed to. Otherwise, you can run into some trouble there. So you may want to think about automation and standardization there. The billing, is a component here too, right? So in the one VPC, the billing might be complex. There might be multiple organizations using the same thing, so you have to be very careful with the tags, those kinds of things. If you have lots of accounts, each person has their own account, then it's pretty easy to do that, the billing. So that's maybe one component. And then you get into sort of the security and the blast radius components, which is, what happens if that one account, maybe the developer writes a for loop and just forgets to do it right and just floods the API, right? Then your production people can't use the API either. So then, okay, well, let's split out development and production. You get to this blast radius sort of scenario, as well as some of the security concerns. So like I said, like the root key scares people sometimes. So you have to be very careful with that. And sometimes that's easier to manage with lots of accounts or lots of VPCs. So the way I usually break this down for customers, there's obviously a lot of sort of ins and outs here. So what I usually sort of summarize this down is if you are a policy and sort of access person, the larger VPCs are probably closer to what you're going to be good at. Me, I'm a network guy, I'm an infrastructure guy, so I'm totally biased here. I spend a lot of time with infrastructure and network people, so they're comfortable with that. They like building lots of networks, and that's just something they've got sort of a culture of and they know how to do. So they sort of go on this orange path here of lots of accounts and those types of things. So there's no right or wrong here. Like I said, it's a gradient of sort of decisions. But if you end up going down the path of like one really large VPC, this talk's not really going to do much for you because it pretty much already covered all the stuff you need to know if you have one VPC. So there's a lot of other sessions here. This is sort of just for resource, for reference. Most of these sessions have already happened, but go and think about other approaches here. There's some security concerns. There's networking concerns. A lot of ways to sort of think about this VPC and account sort of approach. So what we're going to do here is we're going to focus on a couple things. One is, we're really comparing things here because if you came here looking for like the magic answer, there is no magic answer. It's design, right? So design is always taking trade-offs, figuring out what's going to be right for you, and so that's really what we're going to plan on doing here. We're focusing on a couple things. One, scale, right? Because we're thinking towards hundreds of VPCs, towards tens of gigabytes and hundreds of gigabits of throughput at some point, right? What does that look like? Connecting VPCs in multiple sorts of scenarios. And when we start thinking about scale, we also need to think about automation. So what does the automation look like? So there's a couple different design patterns we're really going to spend some time on. We're going to talk about the Transit VPC. I think every session I've gone to so far, people come up to the front and they go, tell me how Transit VPC works, or tell me about this. So we're going to get through a lot of that stuff today. And there's two components to it. There's sort of the Transit VPC. There's also a component with firewalls. We're going to talk about what does this look like if you're using Direct Connect? How does that impact it? We're going to talk about shared services models. So if you have some sort of shared service you want to share to many VPCs, what does that look like? And then also, we're going to talk about multi-region things. So this is sort of like the blueprint of what we're going to go down. So let's get into it. So this is sort of our starting point, right? Up here we've got VPN, we've got Direct Connect coming into our green environment, where we've got a development and a production VPC. So, in this case, just for the simplicity of talking about options, I've put both VPN and Direct Connect up there. But this would be a highly available network, so this is sort of our starting point. This is pretty simple. This is where a lot of customers are at. You've got two VPN tunnels, or two VPN connections, which is actually 4 tunnels, and a couple Direct Connect, connections in here. And then, I don't know, then the blue group joins us. The blue group, they've got 4 VPCs, so they've got maybe 2 lines of business. And now, things are starting to look a little less clean. There's a lot of connections here. So, I was talking with a customer this week where they said, every time we add a VPN connection, we have to open a ticket with the networking team, and they just, either out of laziness or contractual reasons, it takes 45 days for them to do anything. And so, you don't want to add, we're all about agility and scale, and you don't want to wait 45 days for a VPN connection. So that's, and there's a lot of them too. So some network engineers really like tunnels. A lot of them don't. And so you would like less tunnels in a lot of cases. As well, let's talk about connecting these things, because right now, when these guys want to talk to each other, it's going back on premises, whether you're using VPN or Direct Connect. it's going to some other device just to do for these things to talk. So obviously VPC peering is a good idea there. So let's just say we want to connect development and production. So what that's going to look like is we're going to have 3 VPC peering connections, right? But then they go, yeah, actually the whole blue environment really wants to talk to each other. So what does that look like? Okay, well, that's just another 4 peering connections. Still pretty simple. So if you're in the 6 VPC stage, this still makes sense. But what if we go beyond that? What does it look like? So we got the pink guys. They just came up, and the blue guys added some more stuff. So now we're looking at other problems. We've got a lot more things to add, a lot more connections. How do we scale these things? And so the sort of main option that we're using right now for this problem is the Transit VPC. So the Transit VPC is basically a centralization point where we've got some VPN instances, and they do the sort of the east-west and all the connectivity for this. So essentially, once you add a VPC to the Transit VPC, it has access to every other VPC, right? So what are some of the benefits here? So centralization is a component, right? Less tunnels, easier for me to go manage that pair of devices. Also scale. So VPN, with its goods and bads, one of the good part of VPN is it's really scalable. You can do thousands of them. And they work everywhere. VPN works over regions and accounts and different networks, so it's highly scalable. As well as, as inter-region. So obviously, we had a pretty exciting announcement this week about VPC peering inter-region, which, yes! That was exciting to be there for that announcement. So that actually has reduced the requirement for Transit VPC a bit. And we'll get into what that actually means. But sometimes it's also about just being familiar. I've still got Cisco commands on my fingers in my mechanical brain that I just can't get out. Some people like continuing to do that. So some people like what they know. And that's one benefit. As well, we're going to talk about security a little bit and how firewalls get inserted. So Transit VPC tends to be a pretty dominant deployment model for firewalls. And then also encryption. We like encryption, we like security. And so it's a good way to do things like encrypt over Direct Connect and encryption everywhere. So there's sort of 2 components that we're going to talk about around Transit VPC. The first one is the architecture. So I'm going to speak generally about how this thing is built, what the sort of theories and why we made these decisions. And then we're going to go later into the Transit VPC automation that AWS built. So we're going to start off sort of more with the theory and the architecture. So first we have VPC with the Internet Gateway, pretty basic. We have 2 availability zones. A subnet is specific to an availability zone, so we create a subnet in each one. We put a VPN instance in each subnet. Pretty straightforward. From there, what we do is let's add a spoke to this. So what we're going to do is create a VPN connection from one of these boxes. So that VPN connection, for the purposes of this presentation, and there's already too many lines everywhere, so the VPN connection, when you create a VPN connection, actually has 2 VPN tunnels. So every time I draw a line up here, it's actually 2. So keep that in mind when we start talking about VPN tunnel count. For the rest of the presentation, I'm just going to sort of ignore that. Over that VPN connection, we're going to run BGP. That's doing our dynamic routing updates. And from there, we're able to propagate the routes that we advertise from this VPN instance into different subnets. So on each route table, you have the option to basically propagate routes from the VGW. It's basically a checkbox. And so when you do that, when you look at the routing table, you'll see now we've got a route to the 10.0/16 network, which is, in this case, the Transit VPC. And it says that it was propagated, and the route is to the VGW. So the good part of this is that no matter what happens to those tunnels, that route doesn't change. The route still points to the VGW. It's highly available. So that's a really important component of why we're using the virtual private gateway here. So the VGW, by default, is going to advertise the VPC CIDR range. So in this case, it's the 10.1/16. And then the good part here is actually this looks exactly like what you would do on premises. So I just gave you the VPN primer. But for the purposes of the virtual private gateway, it has no idea that we're doing some sort of funky Transit VPC thing. Right? It thinks the Transit VPC is a customer gateway. It probably thinks it's on premises or something. But effectively, we're not doing anything different with a VPN. We're using built-in functionality, which actually one of the nice things about this is that if this is not your VPC, this is maybe a developer or someone else's VPC, you're using totally native services and there's nothing in there. So it's very easy for them to sort of have this demarcation of, yeah, whatever's on the other side of that VGW, I don't care, I don't have to manage it, I don't have to do anything. So that's a nice component. So let's add another one. So we create a VPN connection to the other instance. Then let's add another spoke. So when we add another spoke, we're going to create 2 more VPN connections to the virtual private gateway. So full mesh, basically. Inside of that, we're going to have a route to the VGW. In this case, you really don't need the 10.0/16. They really just need to know how the other spoke. So for simplicity, we're just going to show the 10.1 route. From there, the VPN instances are going to basically route to each other. So when packets come over the VGW, they will be sent to the other spoke. And you can control what gets advertised from these Transit VPC instances. So that allows you to do some control. By default, we're just going to assume for the rest of the presentation, basically, that the virtual private gateway re-advertises everything it receives. So this can also be used for the internet. So some people want to centralize internet connectivity. You can do that. What do you do there? Well, we just have the Transit VPC advertise a default route. And now we can make that work. And one of the common questions I get is, why didn't you just use VPC peering? It seems a lot easier than VPN. And it's faster and all that sort of stuff. So let's find out why not. So we're going to create a VPC peering connection from the spoke VPCs to the Transit VPC. In the spoke VPC, we're going to create a route. Basically, we're just going to try to emulate that last slide, and we're going to have a default route to the peering connection. So in this scenario, it just says if you want to go to the internet, go over the peering connection, and they'll figure it out later. Well, that doesn't work. So in this case, the destination IP address is the internet. When that packet gets routed within that Transit VPC, it says like, hey, I need to go to, I don't know, 54 dot something. Where do I go? Well, it says, well, that'd be the internet. This doesn't work. That is what we would call transitive routing. And so effectively, if you want to think about sort of a theorem, I don't know if this is a law, but it's a theorem at least, that if the way to define transitive routing is either the source or the destination for every packet needs to be a network interface in the local VPC. So in this case, I'm coming in over VPC peering and trying to go out the internet. Neither one of those is a network interface in the VPC. That means no bueno, which is Spanish for not routing. So yeah, you have to worry about that. So transitive routing, that's one of the reasons why we're doing this. So if we go back and we take a look at this with the VPN, what ends up happening is we've got that VPN connection. The destination is the internet. It goes to the VGW. The VGW terminates the tunnel on the VPN instance. And so it lands on the VPN instance here. From there, the VPN instance is going to forward it to the internet. In this case, the source IP address, or the source is the network interface of that VPN instance. So now we're bueno again. We're now forwarding. So that's sort of why we're using VPN. So let's take a look at, most of the time when I talk to network engineers about something, I explain it, they say very nice, and they go, how does it break? So let's find out. In this case, we're going to break one of the VPN tunnels, either because something on the AWS side broke for that tunnel or someone misconfigured a tunnel. Something happened on that one tunnel. What ends up happening here is there's some protocols that are decades old, dead peer detection, which runs on VPN. It's on by default. And BGP has their keep alives. So from a timer perspective, we're going to understand that. And sort of one of the nice things here is that we're also not using any sort of proprietary failover stuff. This is decades old networking protocols. And as I discussed earlier, the route inside the spoke VPC points to the VGW. That VGW route will automatically switch over to the other tunnel. So you don't have to do anything in the spoke VPC, which is really important. So let's break something else. Let's kill an instance. Things always fail, right? So instance fails. What happens? So both those tunnels go down. And again, the spoke VPCs, again, they're going to have timers. So both those timers should detect that failure within 30 seconds. Those are the default BGP timers and the default dead peer detection timers. So that's on by default. It's just there. And that's going to work. So that's a really nice availability concept for HA. If we want to connect on premises to this, what do? There's a few options. So the first sort of more obvious one is just do a VPN over the internet. We can also say, well, look, man, I don't really like the internet much. I want to do Direct Connect. I want it to be private. OK, we'll run tunnels over Direct Connect. And then we've also got this sort of this wonky thing called the Detached VGW. And you hear this a lot about the Transit VPC specifically. So let's dig into these options a little bit. So the first one is going over the internet. So in this case, we've got our same topology. We've got some on-premises data center stuff. And you just create tunnels. And you terminate them on a router or firewall or whatever you like on premises. So that's pretty straightforward. The reasons you want to do this is, one, it's pretty simple. Allows you to sort of really control that tunnel because it's terminating on a device you have full control over. It also gives you the functionality if you want to do some other options for the tunneling. So if you want to do GRE, like an unencrypted tunnel, potentially for higher performance, or if you want to use something like the Cisco DMVPN to do sort of a multi-point VPN, you have options of how that tunnel works. But it is manually configured and operated, right? And that tunnel also has to terminate at one place. Or you create more tunnels if you want to terminate in more places. And that, depending upon where the traffic's trying to go, that could be a challenge. For Direct Connect, I'll walk you through Direct Connect a little bit. The first step is figure out which Direct Connect location you want to be in. From there, you have some sort of way of getting to that location. So that could be at least fiber. That could be a partner network. You could already be in that. So if you're already in Equinix and we're in Equinix, then all you need is a cross connect. Either way, you figure out how to get to that Direct Connect location through sort of networking. You put a device there that's going to do the BGP and VLAN components of Direct Connect. You would create a virtual private gateway attached to your VPC. And then the last step is creating a private virtual interface or private VIF. From there, then you just create tunnels. So when we think about this design, it's great because if you want to encrypt over Direct Connect, this is a great way to do that. So you're using a private circuit. You're getting predictable latency, those types of things. You can also, again, since you have control of those tunnels, use alternative tunnels like GRE and DMVPN. But again, we're still mostly manually touching and operating this thing. So let's take that same use case here where we've figured out our Direct Connect location. We've got a device doing that stuff. This time, we're going to create a virtual private gateway. We're not going to attach it to anything. We just literally just go to virtual private gateway, create new. You've now created a detached VGW. From there, in your Direct Connect configuration, you create a private virtual interface to that virtual private gateway. So it just looks like a normal. Again, from Direct Connect, they have no idea whether it's attached or not. It looks the same. Now, one note here, and this has been a recent addition, is Direct Connect Gateway requires you to attach it. So this is not compatible with Direct Connect Gateway. So then what we do is now we create VPN connection from our VPN instances to the detached VGW. Why would you want to do this? Well, what's sort of nice about this is now you can sort of consider on-premises as just another spoke. So from a design perspective, it's nice and consistent, right? So it looks the same. When we get into the automation components, it's a lot easier to automate this because we're not doing sort of one-offs. It's automated in the case of our Transit VPC. Another advantage is once the traffic comes off the VPN instances onto the virtual private gateway and goes onto the Direct Connect network, after Direct Connect, it's your network. So you can sort of fan that out to multiple locations, all that type of stuff. So it allows you to sort of fan that out connections. And the VPN termination happens closer to AWS, and further away from on-premises, so you can sort of go multiple places. But if you do care about encrypting your WAN connections, this would be unencrypted after it leaves the virtual private gateway. So let's dig into automation a little bit. This is sort of the cool part. So if you're not familiar with CloudFormation, it's a service that we have that allows you to do things like infrastructure as code. Essentially, it's a big JSON or YAML document that describes what your architecture or your configuration should be. So in this case, we go back to our sort of hub. In this case, we put Cisco Cloud Services Routers, or CSRs. The CSRs, if you know Cisco iOS, It's that in a EC2 instance. It's available off of Marketplace, or you can talk to Cisco people and get your own license. We call that bring your own license, or BYOL. One of the reasons why we chose Cisco for this automation solution is that they, inside their operating system, they have support for virtual routing and forwarding, or VRFs, which handles a special VPN case of duplicate addresses, which we'll get into that a little bit as well. So let's talk about what this automation looks like. So first off, you have your CloudFormation template. You can choose a speed and feed, run it in the region of your choice. From there, it's going to create what we showed earlier. By default, it's going to use 100.64, which is a carrier-grade NAT sort of special IP space. You can change that. It's going to create an S3 bucket. So that's where we're going to store our VPN configuration. It's also going to create an S3 endpoint so that we can access that S3 bucket privately and create the route so we can get there. As well, when we had talked about killing instances before, you can now do EC2 auto recovery. So auto recovery means if that instance fails, we detect that failure at an EC2 level. Then whenever we detect that, we will boot it back up and start again. So we added a little additional HA to our previous scenario. So what does it look like to add a spoke? So in this case, what we do is we put a tag on the virtual private gateway. So when you create the CloudFormation template, you can specify what you want that tag to be. So in this case, the default one is Transit VPC spoke equals true. What happens is there's a timed lambda running every minute looking for that. When it sees that, it goes, oh, looks like we got another spoke. So it creates a VPN connection for that VGW. From there, it takes that VPN configuration and puts it in an S3 bucket. On that S3 bucket, we're using key management system, AWS KMS. So KMS is doing server-side encryption on that bucket to make sure, good security practices, we're encrypting things that are important like VPN configurations. From there, the S3 bucket, there's a lambda watching that S3 bucket for changes. When it detects the changes, it downloads those configurations and uses basically a Python thing to basically send those commands down to both of the routers. So there's a security group that allows that Lambda function to securely communicate with those instances. So in this case, the CSRs have now been given the configuration for the VPN, and presto magic, we've got VPN connections. And all we did was put a tag on it. So this is really attractive because now people that don't know networking, you just tell them one thing, like put this tag on it, poof, magic, network connections. So that's a really nice benefit. If we want to remove the spoke for whatever reason, it looks pretty similar. We just change that tag from true to false. The timed Lambda function is also looking for that. So it sees that change, knows what configuration you have, goes to Lambda, says, hey, go delete all that configuration, and then the CSRs will delete those VPN configurations, so just in reverse. If you want to do this to another region, so if you've got a VPC in another region that you would want to add to this, all you have to do is just tag it. So the Lambda function looks across all the regions and automatically does that. So that one, we're good. We don't have to do anything sort of extra work there. If you want to do this in another account, there's a few steps we're going to have to take. So in this scenario, the Lambda is going to run in the spoke account. And there's three things we have to do. One is we have to set up that VGW polar, that Lambda function. We need to allow bucket access so we can access the bucket in the other region. And it also needs to allow KMS access. So the first step here is doing the polar. So the way this works is there's a separate CloudFormation template you can run in the spoke account. And that spoke account essentially sets up the Lambda, sets up the timing, looking for the tag, those types of things. The next one is allowing bucket access. So we need to make sure that our S3 bucket allows this Lambda function to put things in there. So there's a few ways to do that. So this is just an example, what the example code looks like. You basically add another account in your S3 bucket policy. Optionally, when you set up the CloudFormation template the first time, the main template, you can specify up to one other account that you want to add as a spoke. If you do that, this happens sort of automatically. As well, for KMS, KMS needs write access to this bucket. So you add another account ID to your key policy. And again, same thing. If you want to do this at setup, you can allow one other account in the CloudFormation template and do that. Otherwise, you can go edit this key policy. So we've done those 3 steps. Presto magic. We've got VPCs running in another account. Great. So let's talk security a little bit. So I know this conference, I've had a lot of conversations about firewalls and inspection and how do you do that in the Transit VPC. So let's take a look at putting firewalls there instead of VPN instances doing routing. So first, the first thing is like, why? We ask that a lot. Just because you can doesn't mean you should. Is sort of a lot of the questions I get with customers around firewalls and the cloud in general. So my opinion is that there's probably a lot of people that went to AWS to get away from their firewalls. So the operational things you're doing with your firewalls are actually important. So just because the technology works, you also want to make sure your operations and your automation, because we're just going to be back in that same thing where you put in a change and now the firewall engineer takes 45 days to make a security change instead of the network guy. And so be careful about that sort of thing. But the types of customer use cases I'm seeing for this are maybe AWS is considered like an untrusted data center. Maybe it's for bursting or whatever reason, or they just don't trust AWS yet. So they want to put a firewall and inspect everything. That usually goes away after time, by the way. They tend to trust us as they start using us more. There's also compliance requirements around intrusion detection, intrusion prevention, sometimes contractual, sometimes security controls. There's also security organizations really like next-gen firewall and application-level policy inspection, those types of things. Sometimes that's a requirement. As well, once you start doing this, if you've got 100 VPCs, you probably don't want 100 firewalls. So how do you centralize that? And it also helps you get more visibility sometimes when you centralize that too. So that's why this tends to be a pretty common pattern. So if we go back to our diagram, now we've replaced the VPN instances with firewalls. It's mostly the same. One of the big differences is that firewalls are stateful. That's sort of like their whole purpose. So what you want to do is do AS path prepend on the firewall so that one of the firewalls is a more preferred route. You can do that with the routers as well if you like determinism and knowing which of your routers is active passive. But with firewalls, it's basically a requirement. So let's talk about some issues here too, right? So there's this issue of duplicate tunnel addresses. So like I said, that's one of the reasons why we chose a CSR for the Transit VPC. So if we take a look at this a little bit deeper, when we create the VPN connection, there's a VPN configuration. That gets pushed down to the firewall to create the VPN connection. If we look inside this guy, we'll see something like this. This is just an example of Palo Alto configuration. So up top and below, we've got a 169.254 address. It's a /30 point-to-point. That address is randomly generated by the virtual private gateway. So that's good. We don't have to do any work. But let's create the other VPN connection now to the other VGW. That VGW doesn't know anything about the other VGW. They don't talk. They're separate. So he also randomly generates a configuration. And in this case, we rolled the dice and we got unlucky. Both of these VGWs gave us the same address. So they're both expecting us to use 169.254.45.210. So now we've got options. We could just try again. We could delete that VPN configuration and just create a new one, roll the dice, and hope for something better. The way the math works out is sort of interesting. It's the birthday problem if you're a statistics person. So there's 366 unique birthdays. At more than, I think, about 22 people in the room, someone's going to share a birthday. So I'm pretty sure some of you guys share birthdays. But the same math applies here. And basically somewhere, mathematically speaking, somewhere around like 8 to 10 VPCs, you have about a 50% chance of getting an overlapping address on a new VPN configuration. So firewalls typically don't support duplicate addresses on their interfaces. So I've got some good news. Maybe 6 weeks ago or so, we sort of quietly announced this feature to define your own tunnel address on your VPN configuration. So in here, you can assign both the inside CIDR for both tunnels that allows you to define your own address. Now, you do have to do some basic IP management to make sure that you're not giving yourself the same address twice. But you do have the control to create your own addresses on the VPN configurations. This also applies if you're doing lots of VPNs back on premises. So if you have like one big router that has a VPN configuration to, and I've seen it with customers that have VPNs to hundreds of VPCs. If you take that approach because you're one of the people that likes tunnels, this also makes that life easier for on-premises VPN. Cool. So there's another approach here that, that we see is, okay, well, why are we using the virtual private gateway? Can't I just put another VPN instance in the spoke VPC and do VPN there? And the answer is yes, you can do it, but it works a little bit differently. So in this case, we put a VPN instance in each of the spoke VPCs. And what we've done is we've created a route table entry to the network interface of that instance. Now, you could run multiple instances, and there's some other high availability tricks around moving the network interfaces or moving routes. But we're not really going to get into that. But you'll need to figure that out as part of this. So this is good for, it gets you even more control. Because now, you don't have to wait on the VGW. You have full control of that instance, and you can do whatever you want. You can do all sorts of tunneling. You can also do other functions like firewalls. So you can put firewalls in the spoke VPCs. But now we're managing things, right? Like AWS likes to have managed services. Customers like managed services, what I've found. So now I've got to manage these instances or firewalls in each VPC. So you want to think very carefully about how you're going to do that. Automation's important, right? But one of the things I said before is if this is not your VPC, if this is a developer, you've now put an instance in their VPC, and they're like, man, I don't want an instance of my VPC. That's not mine. It's yours, and just, I don't like it. So it's not native. It's a little bit more intrusive in that VPC. But if you figure out the policy, you can sort of make that stuff work. And one of the other things you want to think about is how you're going to get routes into those routing tables. So if it's a default route, it sort of makes sense. But if you're doing some sort of BGP, we no longer have that sort of convenient checkbox feature to propagate routes. So that makes it a little bit more challenging if you have sort of complex routing requirements that need to go to this instance in your VPC. So we've got another sort of design here around this. So if we expand this out a little bit, and maybe we've got multiple availability zones, and what we're going to do here is we're going to put a firewall or an instance in every availability zone, or potentially every subnet, depending upon what you want to do. And what we do is then do a full mesh VPN configuration for all these guys. So why would you do something crazy like this? You also have the routes pointing to each network interface, but it's really scalable, right? Like there's no limit to how many instances you can have in this. Like just go crazy there. The tunnels, like I said, tunnels are highly scalable, so you can do that. If you have a firewall or an instance in each availability zone, then if you lose one of those, then you lose one availability zones. Hopefully, you're running applications that can support that level of failover. If not, this may have some issues for you. But if you've got application level failover, you can lose one of these, and it should just route around it. It should be fine from an application perspective. Some of the other components you want to think about is, again, is centralized management and overhead. When you're choosing a sort of solution that uses this type of design, they typically have that, but you do want to sort of keep that in mind. The negatives are, if you guys pay for firewalls, you guys know that it's typically by the box. So now we've got lots of boxes, so we've increased our licensing costs. And the other one is just sort of like the high management overhead, right? Like I said, managed services are nice when we can use those, and the route propagation is still a problem. I do want to get a shout out here to Barracuda, because they actually just changed their licensing model to be bandwidth-based, so that box-based licensing is not there. So it's a nice little feature to help out. So let's talk about the rest of the ecosystem. So I talked about Barracuda. There's some other folks. Obviously we chose the Cisco CSR when we built this solution out. So there's a lot of folks here that do sort of more routing-based functionality using the VGW. So if they're using our VPN product as the spoke. And there's a bunch of people doing firewalls too. So this whole group of folks. But effectively, really anyone that's doing both BGP and VPN, and they can support that to our virtual private gateway, it really could be anybody. If there's some other logo that I missed here. And there's another sort of group of people that are doing this instance-based sort of transit VPC. And this is basically anyone can just do tunnels, because it's just instances with tunnels between each other, right? So then we can actually classify these further by the level of automation. So I'm going to start with the folks that what I would do consider like continuous automation. So this is sort of the Transit VPC where you're getting tags and you're seeing it, and things just sort of happen automatically. So these folks in orange are sort of on that. There's these other folks in blue that they have a CloudFormation template to spin up sort of your first Transit VPC, but then usually you have to do something per spoke manually or some clicking's involved. And then all the folks in green is basically sort of, they may have some tools or it may be sort of do it yourself. But like I said, anyone that can do like BGP and tunneling and VPN can build a Transit VPC, but then it's really about the automation component. Cool. So I got bored. I made this cool animation. But let's talk about the cost, scale, that type of stuff. That's another question I get a lot of. So let's dig in a little bit there. So this is our Transit VPC. Let's go down. So per spoke, there's a charge per VPN connection. So there's 2 VPN connections in this design. So double the hourly cost per spoke. There's also the egress charge to the Transit VPC. There is also egress charge at the Transit VPC itself, so traffic that's either going back on premises over VPN or Direct Connect, or out to the spokes coming maybe from there. So there's some transit charges there. Inside the Transit VPC itself, there's obviously the EC2 charges of those 2 instances, and any maybe licensing costs. You can also use open source, but that's there as well. If we take a look at some of the performance, I work really closely with the Cisco team, so they helped give me some of these numbers and testing they've done on their platform. So this is basically what you can expect from a performance perspective, mostly for reference. I don't expect really anyone to memorize this. But do want to call out one thing is that the packet sizes for this are basically perfect packets, 1,500, 1,400 byte packets. So if you're not sending those, then you may not get these numbers. So let's dig in a little bit there. So we got our familiar nice Transit VPC again. Basically, from a security perspective, we really recommend using security groups inside the VPC. That's going to save bandwidth costs and make your life a little simpler if you can. Each spoke is going to have two VPN configurations. And so each VPN tunnel itself can do about 1.25 gigs. Roughly, you might get more, you might get less, depending upon packet size. If you have more than 100 VPCs, you're going to run into routing table limitations, because by default, each spoke VPC advertises its CIDR range, and it gets re-advertised out to everyone else. So at 100 VPCs, you'll need to change that routing. So you can customize that, or you could just create another pod of Transit VPCs. Each of these CSRs or VPN instances, and this is basically true across everyone on that slide I had with the pretty colors and stuff. Everyone's somewhere between about 1 to 3 gigabits per second, depending upon packet size. So sort of think about that as you think scaling out. As well, for high performance applications that maybe that bandwidth limit seems low, you can still use VPC peering, right? You can still do that for direct connectivity, maybe on a one-off perspective. So that's still pretty easy to do. It makes it more manageable and sort of on a needed basis. All right, but we're still thinking like hundreds and thousands of VPCs. What do we do now? Because some of these limits don't seem that high. Well, we just make more. So you have one Transit VPC, create another one. When you do this, you probably want, and this could be multi-region, this could be in the same region. One thing you want to think about also here is you probably want to use different tags. So by default, you're going to use the same tag. So you really want to have, is this thing okay? You want to have different tags for different Transit VPCs. So think about that. And then to get east-west connectivity between these things, just create some tunnels between them. And that's sort of how you can scale that out. Cool. So that's what I've got on Transit VPCs. Obviously, it took me a while to sort of get there. It's pretty complex, but obviously there's a lot of value there. So let's talk about Direct Connect, because it's a different sort of way to think about this. So here, what we've got is on-premises on the left. We've got our sort of VPCs on the right. We've chosen our Direct Connect location. We've got a customer router. There's an AWS router. So this is pretty simple, right? So basically, for each VPC, you create a private virtual interface, or VIF. That's a VLAN and a BGP peering session. You can get up to 50 virtual interfaces on a single port. That's for 1 and 10 gig direct connects. For just the purposes of good practice, we're going to make this highly available. And we're going to create 2 more virtual interfaces to each virtual private gateway. And there's actually a lot more sessions, like Steve Seymour has a deep dive on Direct Connect and VPN. If you're really curious about how this works and how you set this up, there's a lot more information on that. But we're really going to focus on the scale here. So for that physical port, get you to 50 virtual interfaces, which translate to 50 VPCs. There's also, that physical port is 50. So we also have a feature called link aggregation, or lag. So you can link aggregate up to 4 links per direct connect. So that now multiplies by the 50, so that's now at 200. So that's a little trick to get you higher than that. So you may want to think about that as in terms of your bandwidth. Do you prefer 2 1 gig ports that both have 50, or 1 10 gig port that has 50? You can do some more math there and figure out what your requirements are. And then we've got this new thing called Direct Connect Gateway, which actually makes this better. So the one starting point that at this moment we have to talk about is it needs to be in the same account. So that is what you need to think about. But from here, what we do is we create a Direct Connect Gateway. We create 1 virtual interface from each of our routers. And then we attach those VGWs to the Direct Connect Gateway. So this scales up pretty high. Right now, when it launched, I think it was 30, but now it's 10. So you can launch up to 10 virtual private gateways per Direct Connect Gateway. So that's nice and scalable. If your accounts and the math all works out the right way, we have 50 virtual interfaces. So I can go to 50 Direct Connect Gateways. Those Direct Connect Gateways can each scale out to 10 VPCs. So that gets you to 500 on a single physical port. So that's it's a big increase, and we're pretty happy about that. So Direct Connect Gateway is pretty exciting. It also works multiple regions. So multi-region connectivity, you create a couple VPCs in another region, you just do the same thing, you attach the virtual private gateway. Oh, that went a little fast. So it looks basically the same. So this is really nice. So now you can connect, if you have Direct Connect in one location, you can now connect privately all over the world. Pretty awesome. So let's talk about shared services. So shared services VPCs are pretty common. I see these typically have workloads like maybe a Microsoft AD server, or maybe you've got a DevOps tool set that you really like, or maybe you've got a logging and monitoring server, security services, those kinds of things. And what we typically see here is VPC peering. So you create all those things in one VPC. You do VPC peering to all of your application or spoke VPCs. And it mostly works. There are a couple challenges with it. So in this case, we're back to sort of our 5 VPCs. And we've got our shared services. There's a couple things that we can improve here. So first off, is you're pretty much allowing full VPC configuration between the two. It's a pretty blunt instrument in terms of routing. You can get more specific with your route tables and those kinds of things, but you're basically allowing both VPCs to talk to each other. If you just want to talk to one service, it's a little bit inefficient there. As well, do we have any developers in the room? Oh, okay. Okay, I won't say anything mean. But if our developers, I don't know, just accepted the defaults on all our VPCs, and we have duplicate addresses, we actually can't peer these things anymore. So that can become a challenge whenever you want to create some sort of shared resource. Unless you really, really like NAT. You can double NAT and all that sort of stuff. Yeah, I heard all the snickers, yeah. I think people have tried that before. And then also, if we're thinking scale, we can only really go up to 125 for this. So after 125 VPCs, either we need to duplicate this shared services VPC, or we need to start using internet connectivity or something like that. So we launched this week a feature called Private Link. So we released it a couple weeks ago, and that was for AWS services, so for like the EC2 API, or load balancing API, et cetera. But what's interesting now is that for customers and partners, you can create your own endpoint in your own VPCs. So the way this works is up top, we've got sort of, in this case, what we're going to call the shared services VPC. We've got some sort of resource. In this case, let's just call it an API, because it's sort of simple to visualize. And down in the bottom, we've got our spoke. So what we do is we put a network load balancer in front of these API servers. That's going to do our load balancing. We associate that network load balancer with an endpoint service. So, and this network load balancer also gets a single IP address per availability zone. So that's sort of nice if you like the virtual IP concept. From here, we create the endpoint, and those IP addresses just sort of magically show up in the other VPC. And so, and these use addresses from that spoke VPC's CIDR range. So in this case, we're 172.16 up top, we're 10.1 on the bottom. The IP addresses are in the 10.1 space. They just pull a sort of random address there. But it's a local IP address. So one thing, and the way this sort of works is that it's unidirectional access. So the spoke VPC is allowed to request the client VPC. And obviously, responses as part of that TCP connection come back, but things up top can't initiate connections down to the bottom. So that's good from a security services, because if someone gets control of my API server, they can't do anything to all my spokes, which is different than VPC peering. So that's nice from a security perspective. One of the other advantages here is if we've got sort of another spoke, maybe our kind developers created another VPC, and they also created 10.1/16, this works. So you don't have to worry about it. Because it's unidirectional sort of functionality, this just works. So you can do overlapping addresses with this service. So that's nice. And you can see in this case, I randomly chose some other addresses for this 10.1 just to show that there's some randomness there. But the way this actually works is inside that spoke VPC, you'll get basically a DNS name for this service. And in each VPC, that DNS name is going to resolve to those IP addresses in that spoke VPC. So I'm going to api.example.com. It's going to resolve to 10.1.2 or whatever, something, in my local VPC. So it's split horizon DNS. So that's the way that functionality actually works. So this also scales out to thousands of VPCs. So again, this is the same thing we're using for our services. So the EC2 API, as you can imagine, helps thousands of customers do that. And you've now got the same scalability when you build services. So there's also a design for this using the Transit VPC. So I see this fairly often. And just sort of like we made our on-premises network look like a spoke, we can also make the shared services just a spoke. So again, it just sort of works. You don't have to worry too much. Just one note, I do see some people wanting to put the shared services VPC inside the Transit VPC. I tend not to prefer that, simply because it changes the access model. You now have to worry about routing to local network interfaces, and you're now back in the game of shifting routes and shifting network interfaces, those kinds of things. So this is really the model I prefer. But like I said, man, I'm just my opinion, man. So let's compare some of these options. So private link is really sort of the place you should be starting. So if you can provide services through private link, it's a better way to do this. But it is unidirectional. It does use our network load balancer. So those are sort of dependencies that you need to think about. But if you've got overlapping addresses, it's really handy to do that. VPC peering is sort of, it's still there. It's still solid. It still works. But think about the scale there, and think about that security. And for the Transit VPC, it's still fairly complicated. So you're paying a lot. It's operationally more complex than both of these. But if you really like the Transit VPC, it's an easy way to continue doing shared services. So it just fits in that model pretty cleanly. All right, let's talk about multiple regions, right? So this one actually got pretty simple. This is my favorite slide to build, because it was really simple. You can peer multiple regions now, right? That's great. And it just sort of works. It's encrypted, so we do some pretty cool encryption things on the back end to make the VPC peering work. So it's encrypted, runs across our backbone. So it just works. If we compare some of the other inter-region options that we talked about, Direct Connect Gateway is great. It's just for Direct Connect. So especially if you're in the same account, it makes sense to go do that for global connectivity. For inter-region peering, we still may have that challenge around the fact that it's one-to-one. But at least with all the customer conversations I've had this week about it, it's usually for like replication or a very specific use case. So you may not have the requirement to have like many-to-one VPC peerings, but it's really dependent upon your architecture. And Transit VPC, a lot of people are using the Transit VPC for this today. Still works. If you want to, you can also do it over cross-region peering. So you could create a cross-region peering and then do VPN over that if you really want to. maybe if you want control of your keys or something like that. But we've got a pretty secure key story, so I really hope people are using inter-region peering and Direct Connect Gateway here. So this is a slide I really like. So this is sort of how I usually walk down the customer conversation in terms of scale. So between like 1 and 5 VPCs, like I said, most of the stuff at the beginning really covered what you needed to know. It works, right? It's pretty simple. It's pretty easy to understand. It's really when you start getting over that. That's when you start talking about automation. That's when you start talking about, again, at like maybe 10 to 15 VPCs, that's where we run into that duplicate address problem. We start running into some complexities there. At 50, that's where we tend to start hitting some of our limits. So that's the default route and peering limit. So you can get that raised up to 100. As well, 50 VPCs is also where we're going to start thinking about Direct Connect Gateway so that we can start fanning out our virtual interfaces a little bit. After 50, then we get to 100 or so. At 100, we have to start thinking about that route limitation. So that's the amount of both either static or dynamic routes that you can have in a VPC. Like I said, the Transit VPC automatically advertises it to everyone. So at 100 VPCs, we need to go customize that. Either we might want to advertise like the entire RFC 1918 range, or we might want to advertise a default route out of the Transit VPC so that we don't overrun that route limit. At 125, that's where VPC peering, that's the maximum for any given VPC. So after that, we may have to start either using private link or start using or duplicating services, or using the internet. And at 200, that's where maybe we did a 4 by lag, so that's sort of our virtual interface limit at that point. So you said, Nick, you told me you were going to talk about thousands of VPCs. I'm like, okay, let's do it. The answer is straightforward, but not. Use the internet, right? The internet is inherently scalable. And there's a couple tips here, because it's really about security once you start going over the internet. There's a couple hints here. So secure protocols. So use SSH, use TLS. Use secure protocols. Make sure the authentication is strong as well. So don't use passwords, please. Use the certificates and keys as part of this so that we don't have leaked passwords. Bastion hosts are a very common sort of approach here. Essentially, for what that is basically an instance that is open to the internet, but it's sort of your jump host. So you can sort of control that a little more tightly and allow that access to the rest of your resources. And that Bastion host is just on the internet. You can do that. Private link is also a really good option here because of the scale of thousands. So that's one of the reasons why we really like that feature. Cool. So let's talk a couple of tips and tricks. It's a little bit of a little detail here. So, like I said, I've been a network guy for a while. I spent a lot of time with customers historically that were buying hardware, and they go like, okay, well, do I need the 3 or the 6 or the 9 or the 12 version of this thing? Like, what's my network bandwidth going to be in 7 years? Because that's how long our hardware lasts. So I need to figure out what our network bandwidth is going to be. I'm going to spend months and months looking at this and price comparison, and you don't have to do that anymore. Like, stuff changes. Like, we bill you by the second now, so you can just test it out, try it, see if it doesn't work. We also released like a bunch of features here this week, so things change pretty often. So even just the recommendations I give for this type of network architecture, they seem to be changing every 6 months, right? We're releasing new features, partners are releasing new features, scale's changing, and so like trying to create like the perfect custom architecture that's going to get you through the cloud for the next 7 years is a waste of time. So really try to focus on probably the next year and a half or so, depending upon your requirements. And don't be afraid to sort of mix and match these things too, right? Like these are just recommendations. So like segmenting out and also combining these things, right? So you can say, well, for this environment, maybe I use Transit VPC. This environment, maybe I use inter-region peering or private link. Like that's okay. Like you don't have to choose one of these things. And testing's super important. And then you need to mix and match these things up too. Cool. So this is mostly for reference. I'm going to skip that. This is how you can customize some of these things. There's some Lambda functions. And then you can use tags and some use cases you want to do customization to. So Vicente, so we didn't really talk about any customer use cases, so Vicente is going to talk about what they're doing and how they customize it.
Well, thank you very much, Nick. Hi, everyone. I'm Vicente De Luca. I work for the network engineering team at Zendesk, where most of my job is make sure that packets move fast from A to B without any loss and also in a cost-effective way. So for those of you, how many people know Zendesk here? Oh, that's great. So for those of you who don't know, I'm inviting you to check our website. We are a company that builds software for better customer relationship. So check out our website and sign up for a trial. So coming back in 2015, this is how our internal backbone looked like. We were a traditional internet shop at that time. We run data centers in the United States and Europe, and we relied on multiple VPLS providers to interconnect all of them. And we also deployed BGP, so we could ensure high availability between those tunnels. So early in 2016, we deployed our first VPC in Amazon. And the way that we choose to interconnect this VPC down to our existing network was by using the managed VPN over Internet and public peering. And the main reason of that is that Zendesk and Internet loves each other. So we already rely on Internet to serve our product to our customers, so why not also make sure that our machine-to-machine talk can also use Internet? And to ensure that we were high available, we deployed the best practice that AWS folks already covered in some of our older talks. So we basically run 2 firewalls per data center in active standby mode. These end up with 16 IPsec tunnels into this model, but only 4 are active. And we have to play with BGP, prepend, and local preference to ensure that the BGP is matching the network topology. So this thing worked very well, and later on that year, we said, well, let's do another VPC. Let's deploy our application closer to our customers somewhere else in the globe. So things start getting a little bit more complex here, and most because when we create a new VPC with this model, it requires configuration changes in all the existing environments, right? And this is a big risk. And it also, we need to ensure that those new VPCs talk to each other. And around that time, there was no VPC peering across the region. So we had to deploy EC2 VPN instances. And now you can just replace this by VPC peering. But you will still need to interconnect this down to the rest of your network. So again, things started working very well. We are a fast-growing company. So early this year, this is how we start looking like. So we had 4 VPCs, all of those tunnels, and things started getting very complicated, especially when we were creating new environments, right? So Nick mentioned that sometimes you have like 45 days delay on setting up new VPCs. We never got that far, but we still have a lot of trouble doing that. And it was time for designing something and thinking of something else. So our proposed solution here was to build a location-agnostic network and also make this network simple and cost-effective for older people to join this. So this network should provide IPv4 and IPv6 with encryption, right, in full mesh topology. It needs to support on-premises data centers and multi-cloud providers, scalable for growth. We wanted to describe our whole network stack as code, so we could fully automate bootstrapping, auto-scaling, and eventually self-healing in case something goes wrong. And we also run Kubernetes in production at Zendesk, and this is also before EKS. Okay. So we named this project Medusa, and the reason is that all of the tunnels that we were handling, it reminds the curly hair of Medusa. So how our network looks like today. So we deploy what Nick presented, a shared services VPC, where we have something like LDAP master or service discovery things. And we deploy Cisco CSRs as DMVPN hubs. So if you're not familiar what DMVPN is, it's basically a protocol suite including IPsec, GRE, NHRP, and internal BGP. And I'll show you how this thing works. So let's say we want to connect our data center to this model. So at our data center, we deploy 2 routers running iOS XE, and we configure them in a vanilla Cisco to Cisco DMVPN. And the configuration at the hubs, 1 minute, okay. We're short on time, so I'll try to get real fast here. So the configuration at hubs does never change. It's everything dynamic. And Let's say that we're now connecting a VPC. This is the secret sauce of our solution here. So we deploy what we call the Medusa routers. The Medusa router is a Linux box, and we deployed this into an auto-scaling group, and we've set up some open source software that reproduce the DMVPN stack. And we also have some custom Python code to propagate those BGP routes that we learned from the network to AWS routing table. Some of the motivations that we have, it's mostly because this is very portable. So we can make this work whenever it runs Linux. And let's say that this VPC needs to talk to my data center now. The way it works is Spoke A sends a packet to Spoke B through the hub. The hub will send a redirect message back to Spoke A and say, hey, you should better build a direct tunnel to Spoke B, so further communication will take the direct path. And let's say we now want to scale N VPCs using the DMVPN model. This is how it looks initially when they come online, but as the traffic converges, we now build those dynamic yellow tunnels, and as you can see, we have multiple tunnels from one VPC to the other, so they can also load balancing across it. So the way that we deploy this in Zendesk, we are a big fan of HashiCorp Terraform. So everything is automated in HashiCorp. We also leverage Packer for building a custom AMI where we have all of our open source daemons configured in the Linux box. And to build a new VPC, we require 6 parameters. So you can just input those 6 parameters, hit Terraform, apply, enter, and wait like 5 minutes. Your VPC will be up and running, all connected to the rest. So the deployment status around this is we're in progress of moving from legacy to the new one. Some of the performance tests that we run, we could increase almost 10 times the throughput compared to the legacy model using managed VPN, sorry. If you're doing this at home, there are some challenges here. You will need an IPAN or a Lambda solution to give a tunnel the next IP. If you're reaching the route table limit of 100, you will want to advertise only the RFC 1918 routes. And stay tuned at early next year because we intend to open source this stack and also write a blog article in better detail. So thank you very much for your time.
Cool.
Thank you.
All right. Well, we're just going to skip through the rest of the slides here. We went a little bit over on time. So yeah, thank you, everybody. We'll take questions up here up front. And thank you for coming.